In the year 1610, a man looked through a telescope and changed the course of history. Galileo Galilei, armed with a crude but revolutionary lens, discovered that Venus wasn't just a bright light in the night sky. It had phases, just like the moon. This wasn't just a curious detail, it was a cosmic bombshell. Because in the old Ptolemaic system, Venus always remained between the Earth and the Sun. It should never have shown a full phase, but it did. That one observation shattered 1,000-year-old cosmology. After Galileo's discovery, the world rushed to embrace the Copernican model. But Tycho Brahe's model predicted those phases too, perfectly. So why wasn't Brahe celebrated? Why wasn't his model declared the winner? The answer lies not in science, but in politics, power, and persuasion. Galileo's telescope didn't just reveal new facts, it stirred old institutions. The Roman Catholic Church had long endorsed the Aristotelian cosmos, with Earth at the centre and heaven above. It wasn't just dogma, it was a metaphysical framework. And when Galileo claimed that the Earth moved around the Sun, it wasn't just a scientific claim, it was a theological insurrection. But what most people don't know is this. The church didn't oppose Galileo because they hated science. They opposed him because he couldn't prove his case to any degree of certainty scientifically. The evidence Galileo presented, the moons of Jupiter, the phases of Venus, sunspots, discredited the earlier Ptolemaic model, yes, but they didn't prove the Copernican model over Tycho's. Both systems explained the phases of Venus, both accounted for Jupiter's moons, both could describe what was seen in the sky. The church wasn't fighting reality, it was fighting premature dogma. Galileo insisted the Earth moved, but had no physical demonstration to prove it. His science was bold, but incomplete. And the Church, for all its flaws, wasn't wrong to ask for more. They maintained that observable phenomenon could not prove the case. Imagine the night sky. Mars, at certain times, appears to slow down, stop, and move backward. This is called retrograde motion. The Ptolemaic model explained this with epicycles. Copernicus solved it with Earth overtaking Mars in orbit. But Brahe solved it using perspective. In the Tychonic system, Mars orbits the Sun orbits the Earth. As Mars loops around the Sun, from Earth's vantage point, it appears to move backward at certain intervals, just as observed. Retrograde motion fully explained. No Earth in motion. No imaginary constructs. And regarding all general planetary motion, it is precisely the same story. Venus and Mercury always appear near the Sun. Jupiter and Saturn wander further. In Brahe's model, this happens naturally. Inner planets orbit the Sun closer than outer ones, and the Sun carries them in its orbit around the Earth. The system works. Accurate tables of planetary positions, derived from Brahe's own data, rivaled those of the Copernican model without ever needing to put Earth in motion. Up to the 17th century, every observable phenomenon in the sky could be modelled this way. No contradiction, no chaos, just a cosmos that moved around an immobile Earth. Evidence that in the late 17th century, a generation after Galileo's discovery, the debate was still unsettled, is shown by the statement of astronomer, geologist, meteorologist and architect Robert Hooke. Whether the Earth move or stand still has been a problem that since Copernicus revived it has much exercised the wits of our best modern astronomers and philosophers, amongst which notwithstanding there has not been anyone who has found out a certain manifestation either of the one or the other doctrine. Some have been instructed in the Ptolemaic or Tychonic system, and by the authority of their tutors overawed into a belief, if not a veneration thereof. Whence for the most part, such persons will not endure to hear arguments against it, and if they do, 'tis only to find answers to confute them. A man born over 100 years later, German geographer and naturalist Alexander von Humboldt, maintained that still the helio model was without proof. He said, "I have already known a long time that we do not yet have proof for the system of Copernicus, but I shall not take the risk to be the first one attacking it." The plain truth that observable phenomena do not prove the movement of the Earth, even up until today, is freely admitted by modern scientists and historians alike. American historian of science I. Bernard Cohen writes, "There is no planetary observation by which we on Earth can prove the Earth is moving in an orbit around the Sun. Thus, all Galileo's discoveries can be accommodated to the system in which the daily rotation of the heavens is communicated to the Sun and planets, so that the Earth itself neither rotates nor revolves in an orbit." One of the world's leading theorists in cosmology, George Ellis, said, "People need to be aware that there is a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with Earth at its centre, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there is absolutely nothing wrong in that. What I want to bring into the open is the fact that we are choosing philosophical criteria in choosing our models. A lot of cosmology tries to hide that." Historian and philosopher of science Thomas Kuhn, referring to a planetary orrery, remarked, "Now imagine that the whole mechanism is picked up and put down again with the Sun fixed at the central position formerly held by the Earth. All of the geometric spatial relations of the Earth, Sun and Mars are preserved, and since only the fixed point of the mechanism has been changed, all the relative motions must be identical. The Tychonic system is transformed to the Copernican system simply by holding the Sun fixed instead of the Earth. The relative motion of the planets are the same in both systems, and the harmonies are therefore preserved." The man considered as one of the fathers of modern cosmology, Dennis Sciama, wrote, "Whether the Earth rotates once a day from west to east, as Copernicus taught, or the heavens revolve once a day from east to west, as his predecessors believed, the observable phenomenon will be exactly the same." It's worth noting that often when these writers refer to a Ptolemaic system, they simply mean an Earth-centered one. Famous scientific writer Stephen Hawking remarked, "So which is real, the Ptolemaic or the Copernican system?" Although it is not uncommon for people to say that Copernicus proved Ptolemy wrong, that is not true. As in the case of our normal view versus that of the goldfish, one can use either picture as a model of the universe, for our observations of the heavens can be explained by assuming either the Earth or the Sun to be at rest. So, what did the proponents of the heliocentric model use to shift the balance of power over to their model? Friedrich Bessel, in 1832, observed something no one had seen before: stellar parallax. The tiniest shift in the position of a nearby star when viewed 6 months apart. Astronomers declared victory. This, they said, was the final nail in the coffin of geocentrism. Only a moving Earth could produce such a shift. As Alan Hirschfeld mentions in his book, The Race to Measure the Cosmos, in Newton's day, the Ptolemaic system and the Keplerian version of the Copernican system were taught side by side in the universities of the world. But the pendulum of belief had swung irreversibly to the Copernican side. In the minds of most scientists, the heliocentric universe had become fact. Yet there remained a crucial missing element in what was otherwise a complete and compelling picture of the universe. Not one shred of indisputable observational proof existed that the Earth moved through space. Here then was the holy grail of many an astronomer: to prove that the Earth in fact revolved in a wide orbit around the Sun. The parallax of just one star, any star, had to be detected. The hunt for stellar parallax was on. But the Tychonian model wasn't disproven by parallax. By making a small adjustment to the model, the entire stellar sphere moves in a coordinated motion relative to the Sun, just like the planets do, with the geometry fully capable of producing the observed parallax. The math works either way. Tycho never needed to explain parallax. He died in 1601, more than 2 centuries before it was detected. He wasn't wrong to leave out this enhancement to his model, which is now called the Neo-Tychonian model. He was simply ahead of his time and never needed it. With these refinements, his model accounts for every kinematical observation made before and after his life. This is confirmed by the University of Illinois physics textbook of 2004, which notes the following stunning admission. It is often said that Tycho's model implies the absence of parallax, and that Copernicus's requires parallax. However, it would not be a major conceptual change to have the stars orbit the Sun for Tycho, which would give the same yearly shifts in their apparent positions as parallax gives. Thus, if parallax were observed, a flexible Tychonian could adjust the theory to account for it, without undue complexity. What if parallax was not observed? For Copernicus, one only requires that the stars be far enough away for the parallax to be unmeasurable. Therefore, the presence or absence of parallax doesn't force the choice of one type of model over the other. If different stars were to show different amounts of parallax, that would rule out the possibility of them all being on one sphere, but still not really decide between Tycho and Copernicus. In fact, if we don't worry about the distant stars, these two models describe identical relative motions of all the objects in the solar system. So the role of observation is not as direct as you might have guessed. There is no bare observation that can distinguish whether Tycho, taken broadly, or Copernicus, taken broadly, is right. In a paper submitted to the European Journal of Physics in 2013, Luka Popov of the University of Zagreb said the following: "The recent paper published in European Journal of Physics aimed to demonstrate the kinematical and dynamical equivalence of heliocentric and geocentric systems. The work is performed in the Neo-Tychonian system, with key assumption that orbits of distant masses around the Earth are synchronized with the Sun's orbit. Motion of Sun and Mars have been analysed, and the conclusion was reached that the very fact of the accelerated motion of the universe as a whole produces the so-called pseudo-potential that not only explains the origin of the pseudo-forces, but also the very motion of the celestial bodies as seen from the static Earth." After the paper was published, the question was raised if that same potential can explain the motion of the distant stars that are not affected by the Sun's gravity, unlike Mars, and if it can be used to reproduce the observation of stellar parallax. The answer is found to be positive. So what does all this mean? It means the Earth may not be moving at all. It means the heavens may still revolve around us, not as a myth, but as a scientific possibility. And it means we must now face the deeper challenge. Because if the Tychonic model can explain all the motions we see in the sky, can it also explain the forces? In part 4, we will take a look into the dynamical evidences, forces and effects that allegedly prove Earth's motion. The Foucault pendulum, the Coriolis effect, the bulge of the Earth. These are supposed to be the nails in the coffin of geocentrism. But what if they're just misunderstood?